Hello and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline, you'll need somewhere to deploy it, so check out Linode. With private networking, shared block storage, node balancers, and a 40 gigabit network, all controlled by a brand new API, you've got everything you need to run a bulletproof data platform. Go to dataengineeringpodcast.com/Linode today to get a $20 credit and launch a new server in under a minute. And you work hard to make sure that your data is reliable and accurate, but can you say the same about the deployment of your machine learning models? The Scafos platform from Metis Machine was built to give your data scientists the end-to-end support that they need throughout the machine learning lifecycle. Scafos maximizes interoperability with your existing tools and platforms and offers real-time insights and the ability to be up and running with cloud-based production-scale infrastructure instantaneously. Request a demo today at dataengineeringpodcast.com/metis-machine to learn more about how Metis Machine is operationalizing data science. And go to dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, read the show notes, and get in touch. And join the discussion at dataengineeringpodcast.com/chat. This is your host, Tobias Macy, and today I'm interviewing Alexander Dean about Snowplow Analytics. So, Alexander, could you start by introducing yourself?
Yeah, sure, Tobias. So, my name's Alex Dean. I'm the co-founder and CEO of Snowplow Analytics Limited, based in London, UK.
And do you remember how you first got involved in the area of data engineering and data management?
Yeah, I've been involved in it kind of on and off throughout my career. So after university, I joined Deloitte Consulting and their business intelligence division, and so I saw there quite a lot of the kind of the more classical data warehousing techniques. So this was back in sort of the early 2000s. So that was my introduction to this space before data engineering was even a kind of a term or a career. A little bit later, I was working at OpenX, which is an open source ad technology company. That's where I met my Snowplow Analytics co-founder, Yali Sassoon. And at OpenX, we had quite early exposure to the whole kind of wave around Hadoop. So again, this was around 2007, 2008. We're doing quite a lot of work on the West Coast and got exposure there to the Hadoop ecosystem. So that was really interesting. That was a step forwards. And then before Yali and I set up Snowplow, we were doing quite a lot of consulting work for clients here in London around e-commerce and digital product businesses and things like that. And there we got quite a lot of exposure to the web analytics scene, Google Analytics, tools like that, and also the kind of growing, burgeoning AWS ecosystem and the data tools that were coming along there, like Elastic MapReduce and things like that. So yes, throughout my career, really, I've had exposure to first data warehousing and classic BI, and then moving into the data engineering, data management spaces with Hadoop and AWS and things like that.
And so can you talk a bit about what it is that you've built with Snowplow Analytics and the problem that you were trying to solve when you first started the company and the project?
Yes, sure. So Snowplow Analytics is an open source project and a company. So it's been an open source project, and we built a company around it from the beginning. So we started Snowplow about six years ago. We, as I mentioned, Yali and I had met at OpenX, and we'd got a lot of exposure to data engineering approaches there. We were then doing consulting here in London for these digital product companies and retailers, and pretty much all of them were using Google Analytics. We were quite frustrated by the fact that we couldn't get at the underlying data. So, we logged into Google Analytics and we could see dashboards, we could see reports, but we couldn't get at the actual underlying event stream, click stream data. And we wanted to get at that data because we wanted to do, ad hoc analyses, bespoke investigations on the data, all the kind of stuff that could actually change those companies and give them competitive advantage over other businesses. And we just couldn't get at that data. And it was frustrating because those companies were able to give us really rich offline data. So, they were able to give us really rich data from their transactional systems, from their CRMs, things like that. And it was a paradox because this new wave of awesome digital data, we couldn't actually get at it. And so from our time at OpenX, we understood this idea of a clickstream data pipeline. We understood that companies on the West Coast were building these and hiring data engineers to put these into practice. We knew that like the way that Amazon Web Services was blowing up at the time, the way that it was getting loads of traction and introducing all these fundamentally data engineering as a service tools like Elastic MapReduce and storage with S3 and things like that. We knew that was really like powerful and a great way of potentially building these pipelines without having to home roll it all yourself using Hadoop and HDFS and all that sort of thing. And so what we thought is, what if we put out a pretty simple prototype on GitHub and just say, look, this isn't that difficult. You can take this, run it on AWS, and have your own event data pipeline. And it was quite unusual. I mean, it was cloud native, if you like, before that was even a trendy term. We designed this all around AWS initially, and we put it out there, and we started to get some really interesting traction. So it wasn't hobbyists picking it up; it was quite big enterprises in Europe, the US, Australia, who wanted to have a clickstream data pipeline like this, and that was really interesting to us. We thought, well, we're onto something here. There's clearly a need for this that isn't being met. There are some pretty big companies here who don't know how to build this stuff themselves and don't know how to build a data engineering team to do this. So that's how we got started. We kept building out functionality. So our initial focus, coming from that consulting work around Google Analytics, our initial focus was around web analytics. So we put in a lot of work to get functionality into the Snowplow prototype to get towards parity with the commercial solutions in the marketplace, and it just really steamrolled from there. That's how we got started.
Yeah, for anybody who has used Google Analytics, that's definitely one of the biggest pain points is you ship all of this information to them and then they expose this weird query API that doesn't really fit any of the semantics that you're used to from things like SQL or any of the other data platforms, and you don't have any way to get at the raw data that you ship to them. So it's definitely a very asymmetric relationship that you form when you're using something like that. And I'm wondering what it is about the sort of customer data and web analytics space that is unique in terms of the ingestion and processing requirements versus some of the other more traditional sort of transactional data sources that companies might already have been working with.
That's a really good question. I think there's lots of interesting differences. I think there's three broad ones. They relate to kind of the volume of data, the variety, and also immutability is really important. So I think to start with volume, what you're looking at when you start collecting customer event data is just an order of magnitude, sometimes two orders of magnitude more data than you're used to seeing from your transactional systems, and that changes a lot of things. That really does force your architectures to be much more scalable, differently composed. You can't use the same kinds of technologies, and it really is a big difference, and it forces some really tough questions around how you're going to store the data, how you're going to manage that going forward. Are you going to keep aggregates? Are you going to keep full archive? All that kind of stuff. So the volume aspect of it really can't be underappreciated. It's really important. I think the variety is really interesting as well. So when you're collecting customer event stream data, you're potentially collecting it from all the different touch points you have with your customers. So you're collecting it from your mobile apps, you're collecting it from your website, from your customer support centers, so many different places that you can be collecting that from. And the number of different interactions and behaviors that your customers probably have with you across their life cycle is so diverse that you're really looking at a lot of different kind of data points. You're looking at a lot of different, even just the types of entity that are tracked through this, and the things that your customers are experiencing with you. So variety, I think, is really big as well. You've got a real diversity challenge to meet there. Immutability is interesting. So when we're talking about event stream, when we're talking about customer events, we're talking about specific actions that your users or customers are taking. So we think of those as almost like facts, things that happened in the past at a specific point in time, and those things are, unarguable. They're immutable. They're facts that you want to track through the system, and that's really important as well. And that's caused some really interesting challenges recently with the advent of GDPR and other data privacy initiatives, where suddenly we're in a world where mutability isn't really acceptable anymore when you're looking at things like right to be forgotten. So yeah, customer event data is really quite distinctive from those kind of transactional forms.
And also, given the fact that it is coming from these multiple sources, possibly even different web properties or mobile applications, there's the requirement for being able to create a canonical record for a given user, even though you may not actually know ahead of time who a given user is, because there isn't necessarily any sort of login information like you would have with a transactional system. So I'm wondering what types of approaches you use for being able to dereference these users or these entities, for being able to create a unified view in the analytics backend of being able to build these reports of how this traffic is correlated.
It's a really good question. So we call that whole area identity stitching, and it's tough. So the starting point that we always kind of encourage is to collect as many discrete potential identifiers from your customers or your anonymous users or pre-logged in users as possible, and then it's a science and an art, identity stitching. So you want to bring those distinctive event streams together. You want to use the different identifiers that you have and try and map them together, essentially build a join table and then use that to reconcile. It's not perfect. A lot of the identifiers will, in the case of things like cookies, they'll get reset or deleted. Many of the identifiers are super, super crude and you need to be careful using them. So it's not perfect, but we find it's really important. If you can, as you say, most companies now have many different channels and they have different concepts of the user or customer in those different channels. If you can do that join process, if you can do that stitching and bring those different event streams together, you end up with a much more interesting view of those users. So it's well worth doing, but it's an art as well as a science.
And as you mentioned, one of the other challenges with event stream data and web analytics is the question of volume. And with that also comes the potential for inconsistency in the data, particularly since it's generally coming from a website, and there might be arbitrary JavaScript loaded on the page that might interfere with your tracking snippet, and the possibility for people willfully submitting incorrect information or just spamming your pipeline to try and create some sort of a DDoS attack. So I'm curious what the collection portion of the Snowplow stack looks like and how you've designed it to be able to validate the correctness of the data and try and ensure the cleanliness of the resulting analytics when it reaches the back end.
It's a really important area. So the way that Snowplow is architected, we start with a set of trackers. So we start with a set of tracking SDKs. Those are the things that you're embedding in your website or in your mobile app or in your server-side systems, and those are emitting events. Those events are then landing on what we call a collector. And the collector is a pretty dumb piece of technology. It just receives the events over HTTP, and then it writes them on into a queue of some form, some sort of message queue like Kinesis or Kafka or Google Cloud Pub/Sub. From that queue, we then have another process, which we call the enrichment process. And that process takes charge of validating the data and then running the various enrichments, which you can think of as kind of widening the event. It runs those on the event. And so coming out of that writes back out to another queue, again, another Kinesis stream or Kafka topic or Google Cloud Pub/Sub queue. And again, that's writing out enriched events. So that's now writing out the enriched event stream. And then we do various processing downstream of that, which is really interesting and important. And would love to drill into a bit later. But yeah, fundamentally those are the most important steps from a data quality perspective. So the collector is deliberately not enforcing anything around data quality. It's a pretty simple pass through. It's there to be a kind of a guardian gatekeeper between the public internet and the trackers, and on the inside the processing pipeline and the queues, the streams. The enrichment process is the piece that's doing that validation and enrichment. And the validation is like you say, it's really, really important. So we quite early on the Snowplow journey, we realized that it was really important for the event streams to be well structured. And the way we got the event streams being well structured was by using schema technology. So we use Json Schema, which is schema technology. It's a way of modeling, representing JSON data. It's a way of saying this JSON data will have this structure, and if it doesn't have this structure, we can reject that data. So we elected to use Json Schema to model the event data flowing through the system. The way we structure that is we ask our Snowplow users to associate the data that they're sending in with JSON schemas. So we get them to define the JSON schema that models the event data that they're sending in. What we then do in the enrichment process is we validate that the data they're sending in conforms to the JSON schema that they say it will. And that's a really powerful technique, because what that means is that we're essentially receiving self-describing customer events. We're receiving events that say, I'm going to fulfill this schema. And then we're checking them against the actual schema, which we store in a schema registry we call Igloo. And we check that they meet that schema. And if they don't, then what we're able to do is we pass them off to a separate queue. We pass them off to a bad events queue. And we're able to store why they don't meet the schema, so why they don't match the structure that we expect. And we kind of hit on that architecture for Snowplow quite early on. It was a reaction to the SaaS analytics platforms that we'd worked with, where what we found is that if the data we were sending in didn't conform to the structure that was expected, it would just be silently swallowed. It would just disappear in the black box. And we wanted to do something different with Snowplow. We wanted to say, you're sending in event stream data from unreliable clients like JavaScript trackers and mobile apps and things like that. You're sending in that data, and if it doesn't match the schema you expect it to, and there's lots of different reasons why it might not match, like you mentioned earlier, Tobias, if it doesn't match, then rather than just silently swallow it, we're going to put it in a separate queue, and you're going to be able to look at that data and understand why it's failing validation, and then go back to the source and fix whatever that underlying problem is.
And that would also help reduce a large amount of the traffic that somebody might be submitting where they're just, bulk generating events because they're not necessarily going to try to match a given schema. They just want to throw packets at you without really caring what kind of information is in them. So you could pretty easily just filter those out as being invalid because they're not conforming to the specified schema and have all the attributes that you need. So it raises the bar for a potential attacker just right off the bat.
Yeah, that's right. So we regularly see, for example, scripts targeting collectors and trying to kind of send in nonsense data, more to probe for vulnerabilities than actually to devalue or corrupt people's event streams. But we see that kind of thing, and you're right. This kind of validation stops that stuff from having an impact. I think we do a couple of other things as well to mitigate against kind of bad sources of traffic. It's a really hard problem because, of course, you're sending, you're putting your tracking SDKs out there in the web, and you're embedding them in mobile apps and stuff. So it's a really tough problem. But we do quite a lot. So we have a couple of different user agent parsers that can help you to identify bot traffic. We have an enrichment that uses the IAB bots and spiders list. So again, it helps you to understand if there are different sources of artificial traffic hitting your site. So there's some stuff we can do to analyze the event streams and figure out if there's sort of traffic you don't want in there. But it is a tough problem. There's something interesting around potentially authenticating the events that we're thinking about, and we might well do an RFC, which is a kind of public requests for comments from our community around that. But yeah, it's a really tough problem.
And on the tracker side as well, I know that one of the issues that comes up with people who are implementing web analytics is that there might be some sort of event that they want to be able to track, and they don't realize that when they initially set it up. And I know that that's one of the problems that Heap has set out, where they just collect every event by default. So I'm curious if there are any default events that you automatically track when somebody sets up the snippet, or what your approach is for making it easy to lead people in the right direction of tracking the types of events that would be meaningful for their business.
That's a really it's a really important area. So we've always done quite a lot of that with the JavaScript tracker. So we've made it really easy to capture page views. We made it really easy to capture what we call page pings, which is someone staying on the web page for a period of time. So we've made that quite easy. We've got kind of automated link tracking. We pull quite a lot of context out of the page, so we can grab things like your Optimizely data or your Google Analytics cookies. So we've always done quite a lot on JavaScript. On mobile, so on iOS and Android, tracking historically has been a bit more manual, but we're doing quite a lot of work there at the moment to capture a lot more around the overall application lifecycle. Because as you say, there's quite a lot of actual standard behaviors, and it's really nice to be able to just put a simple tracking snippet into your mobile app and get quite a lot of that. So it's a auto tracking is an important area. I think that quite quickly you end up in, especially in a web app or a mobile app world, quite quickly you end up in a place where your application probably has some quite distinctive features, maybe some quite distinctive entities that you're representing on screen, or some quite complex data models, and quite quickly the auto tracking will break down around that, because actually you just want those entities well tracked and well modeled in your event pipeline. But yeah, auto tracking gets you a long way before you start running into those issues.
And for somebody who is running the Snowplow stack on their own, I'm curious what types of metrics and monitoring they should be keeping an eye on to ensure that the data is able to be collected reliably, and that you aren't getting a bunch of poorly formatted data, so that you can maintain the health of your overall analytics process.
Yeah, so I think there's two areas here. So there's a kind of more like a DevOps layer, so more of a systems layer, which is around the pipeline health, so the health of the actual services that you're running. And then there's a layer above that, which is around data quality. And you need both, because if you have the pipeline running smoothly, but the data quality is not there, then you have problems, and vice versa. So on the kind of systems layer, the pipeline infrastructure observation, there's quite a few different things there, but a lot of it comes down to latency. So you're really interested in the collectors behaving well. When clients are online and sending data, you want your collectors to be up and available and pulling that in. You want to make sure that the end-to-end latency is pretty good as well. So if you have increasingly, Snowplow pipelines are being used for quite operational use cases. So maybe fraud detection or insight, in-app recommendations, things like that. So you want to make sure that you're feeding those algorithms in a really timely fashion. So you're interested in the end-to-end latency from the events landing at the collector to those events being enriched, and then even after enrichment into the real-time apps that you're writing that are doing the processing. So latency is really important. You need to make sure your queues or streams are really healthy. So with a Snowplow real-time pipeline, essentially you've got a bunch of microservices, and they're reading and writing from queues or streams. So it's really important that those queues or streams are available. They're scaled to the right size, which can be a problem sometimes, and they're key to your plumbing. And then you're always looking for systemic failures. So is there some kind of problem with the writing to Redshift, for example, when we're syncing that event stream out to the Redshift database. Is there a problem with a specific data source for your enrichment? So, have you got some sort of systemic problem in your enrichment process? So you always need to be careful of that and make sure that all those data sources you're joining are available as well. That's on the systemic side. On the data quality side, again, it's really important. So you could have a really low latency pipeline that's working really well and is not having any failures, but actually perhaps you botched the release of your latest iOS app and the tracking isn't quite right in there, and the data being sent in isn't matching the schema, and then suddenly a significant proportion of your data is failing validation. So that's something you need to monitor. You want to be monitoring the volume of events being successfully enriched with the volume of events that are failing validation, and you want to look into those failures and see if there are specific patterns, like maybe a certain event is failing more because that event is the one that got broken by the app rollout.
And we've discussed a number of the different components of the overall Snowplow stack piecemeal as we discuss some of the different layers, but can you give an overall view of the life cycle of a given event as it flows throughout the architecture, from when it first gets registered all the way through to when somebody's running an analysis against it?
Yeah, sure. So the events will start in the trackers. The trackers will try and send the events to a collector. If there are any issues, they'll be held in the tracker and it'll try again. Once they land on the collector, they will be written out to the stream, so the stream or message queue, and then they'll be read from that and consumed by the enrichment process. And it's that enrichment process that is validating the events against their schemas and then adding the extra data from the enrichments, making that event much more meaningful. Once that microservice has done its work, it will write out again to another queue. And then after that, a few different things can happen. So one of the nice things about these stream-oriented architectures is you can have lots of different consumers on a stream. So when the data is written out to that Kinesis stream, the enriched events are sitting in that Kinesis stream. We can put multiple different consumers on that stream to do different things. So one of the most common ones we put on there is a sink that writes the data, writes the events to Elasticsearch. So a lot of Snowplow users are keeping up to 7 days of their event stream in Elasticsearch, and that makes it quite easy for them to query that data, run counts, look at patterns in that data, or even build dashboards and things on top of it. But then equally, we are also storing that data out to S3. So we have another consumer that's writing that data to S3. Downstream from that, we have a process that can prepare that data for Redshift and write that out to Redshift, or indeed to Snowflake DB. And then another really common thing to do with that event stream is to build, as I mentioned earlier, to build real-time apps that sit on that event stream and process it in some way to do something important in real time. So maybe do some real-time decisioning or fraud detection or content or product recommendations. So there's quite a lot of different stuff that can be done. In terms of what happens, so if we take the example of the data being written to Redshift, again, that's not the end of the journey. So a lot of Snowplow users and customers will do further modeling, event data modeling on that data. So, that the data sitting in Redshift is extremely rich, extremely granular. It's very, very common and useful to take that data and roll it up into more meaningful aggregates for the business. A really good example of this is around video consumption online. So if you think about it from the tracking perspective, someone's watching a video and we're sending ping information every 10 seconds, let's say, about, this person is still watching this video. That flows through into Redshift as very, very granular information. Whereas the analyst is much more interested in actually this video view, just, forget the ping information. What was the actual length of time that this person spent watching this video? So there's a lot of that work. We call that data modeling. There's a lot of that we do on the granular data. And you can really think actually of the real-time processing that I mentioned earlier. You can think of that as just data modeling in stream. You can think of that as the enriched event stream is coming in and we're doing processing on that to make more meaningful outputs or decisions.
As you were discussing all the different points that the data flows through, I'm thinking about different ways that you can hook into them and, as you said, add your own processing. So between Kinesis and the enrichment process, or as part of the enrichment stream, or once it hits Redshift, that isn't accessible to you when you're using just a fully managed analytics platform such as Google Analytics, because you don't get exposure to any of those pieces of the system. And for somebody who's running the full Snowplow architecture on their own, they could very easily just run their own processes to hook into those. But for somebody who's using your managed instance, do they also have access to those various different integration points?
Yes, they do. So when we're running Snowplow Insights for a customer, we're actually deploying Snowplow into their own Amazon account. And so the whole of the Snowplow pipeline is running in their own Amazon account and soon in their own Google Cloud account. And so that means that actually they have a lot of that flexibility, and we can work with them to come up with those kinds of custom applications that they want to deploy into AWS and wire into the enriched events. We don't find much use for interacting with the raw events, because fundamentally the raw events are just a format that's taken and processed further by our validation and enrichment process. But once those events have been enriched, yes, exactly. So all our customers can use that stream and build really interesting apps on top of it.
So how has that overall architecture evolved from when you first started? And do you think that if you were to begin again today, that you would make some of those same choices, or were there other aspects that you would do differently?
That's a great question. So the biggest change since we started 6 years ago has really been the shift from batch-based architectures to real-time based architectures. So when we started Snowplow, really the only real-time component was the event collection. Those were, the event collectors were running all the time. They were bringing the events in, and then they were storing them in S3. And downstream of that was all quite a kind of a classic ETL style architecture. So, we would spin up a Hadoop job on Elastic MapReduce. We'd take the raw events, we'd validate them, we'd enrich them, we'd write them back to S3. And we'd have another kind of batch-based process that would do the load into Redshift. So it was quite a kind of a classic, almost data warehousing style approach. And yeah, the really big change in the last few years has been the move from those kinds of approaches to real-time approaches. A lot of that was driven by the guys working on Kafka and that ecosystem. Of course, Amazon launched Kinesis, and that was a really kind of powerful kind of Kafka equivalent running on AWS, and so that was something we integrated with really early on. But the real-time approaches have changed quite a lot of stuff. Like we're now, you think about your event pipeline today, and it's a living, breathing system that's always available. You're trying to get data through it as fast as possible. It's very different from that slightly old school batch approach. There are still some interesting merits of the batch approach around, bulk processing, reprocessing, things like that. But yeah, fundamentally, we've moved to a real-time world. To the second part of your question around what we would do differently, we actually have quite a lot of that question actually comes up, because when we started were on AWS exclusively, we did a prototype around Kafka support a couple of years ago, and we've been working pretty heavily this year on Google Cloud Platform support. And so thinking about what Snowplow should look like on Google Cloud Platform has been a really good opportunity to revisit, the assumptions of Snowplow and revisit how we, designed Snowplow originally. I think one of the most interesting divergences that we did with GCP is we've gone real time from the start. So we haven't focused or even really scoped out a batch version of the Snowplow pipeline on GCP. We've gone straight to using Google Cloud Pub Sub, using Cloud Data Flow, building Snowplow on GCP as a set of asynchronous microservices that run in the cloud.
And that brings me to the discussion of the business aspects of Snowplow and how you're supporting the continued development and growth of the analytics pipeline and the ways that you're helping customers achieve a better view of their customers through these event streams and web analytics and mobile analytics.
So as I mentioned a little bit earlier, Snowplow started as an open source project, really a prototype, but we always had aspirations to develop it into a business and a company, and we realized fairly early on that to build Snowplow out and meet all the requirements that different constituents had for Snowplow, we would need to build a team around it. I think the interesting thing for Snowplow was we knew that a lot of value of Snowplow was in the open access, the transparency, the fact you can you can see the data flowing through the system. And so we weren't particularly interested in building a kind of a hosted Snowplow. To us, that was kind of more of the same. That was more like Google Analytics and other SaaS analytics platforms. So we came up with the idea of a managed service. And so essentially with the managed service, which we launched about 4 years ago, Snowplow users or prospective users would come to us and we would spin up and set up Snowplow running in their own AWS sub account. So they'd give us access to that sub account. We would deploy Snowplow into it. We would manage that. We would maintain it. We'd monitor it, upgrade it. Snowplow goes through a lot of new releases. And that was really the core of the managed service. So another way of thinking of the managed service is to use Snowplow open source, you really needed two things. You needed a sysadmin and you needed a data scientist or perhaps a data engineer, someone who can really work with the enriched event data. With the managed service as it was then, we were saying you don't need to have your own sysadmin. Your internal systems team can go away and work on other stuff. You can pay us and we'll run Snowplow for you in your own AWS sub account. So you'd pay your own AWS bill and then pay us for the managed service. And our pricing model was quite interesting. We were charging a flat fee to deliver the managed service. So we weren't saying that, if you were, if your event volumes went up a bit, we were going to charge you a bit more money. We're saying, no, you'll pay more money to Amazon, but our fees will be flat within certain parameters. So that was really that managed service was really the engine of our growth that allowed us to hire a team, bring in a support team, build out towards kind of 24/7 support for our customers, hire data engineers to work on the platform and keep adding features and all the other necessary facets of business. So that was the kind of a big step in our evolution from kind of open source project to company. Something interesting happened a couple of years ago, which is that we realized that we were doing much more than just providing a managed service. So we realized that we'd actually built a lot of software to manage and monitor Snowplow, and we had aspirations to build an actual kind of management and monitoring and UI for our customers. So we had aspirations to actually give them a kind of a guided self-service experience around the Snowplow pipeline. And at that point, we started kind of moving beyond the managed service into what we call Snowplow Insights. And so Snowplow Insights it's really our kind of commercial product that sits on top of Snowplow and really helps you through the whole kind of Snowplow experience, whether you're a data engineer, a head of data, a data scientist, or whatever. Under the hood, we're still deploying Snowplow into your own AWS sub account and running it for you. That's really important. But yes, you're getting more than just a management process.
Yeah, I imagine that fixed cost overhead for running this full data pipeline was very attractive and helped encourage a lot of people to come on board versus these tiered pricing models that a number of other providers have, where the more data you have, the more you pay, and it's not necessarily a linear scale because of the inherent complexities of larger volumes of data.
Yes, I think that's exactly right. So we found those analytics SaaS models are quite challenging for a lot of companies, because what happens is as you add more and more tracking into your various applications and sites and your event volumes go up, and potentially you're going to go from a lower tier to a much higher pricing tier. And the challenge is that the value you're deriving from those analytics isn't actually increasing. It has a certain value to your business, but the fact that you're suddenly doing 5 times the event volume doesn't mean you're getting 5 times the value. So that's been those SaaS pricing models have often been quite challenging. And of course, there's always a risk with those SaaS pricing models where you've got that tracking embedded in microsites, mobile apps, all that kind of stuff. There's quite a lot of lock in there, so it can be really expensive finding out a couple of years down the line that actually the pricing for your event volumes is going to be pretty high. And a lot of those companies, they do subsidize at the lower levels and charge more at the enterprise levels.
Yeah, the lock-in piece is interesting too, because given the fact that Snowplow has so many different components to it, there's a lot of potential for individual users to be able to swap out some of those different layers for their own preferred platforms that they might already be running for other systems. Even just the tracking snippet, where if you move away from using Google Analytics, then you have to re-implement all of those snippets, where given that yours is open source, somebody can just modify the destination point and then still be able to leverage all of that same information that they're collecting if they decided to build their own in-house platform or go with another provider.
Yeah, there's just a lot more more flexibility in the stack.
And what have you found to be some of the biggest challenges or unexpected lessons learned in the process of building and growing both the platform and the business?
That's a really good question. I'd say that one of the big challenges we found is around the sheer size of the technical estate that we've had to build. What we found over the years is that a lot of the building blocks we've needed to build a pipeline like Snowplow just don't exist in an open source way. So we've had to build a lot of those ourselves, from API clients for enrichments to a lot of our schemaing technology to good, robust ways of writing data into data warehouses and things like that. So it's been really interesting and surprising to us just how much we've had to build, and thus how much our team of data engineers has to maintain. I think that's been an interesting challenge. I think building on top of public cloud, like we have over the years with AWS and we're doing now with GCP, I think that's been really interesting. So the pace of change in those clouds is frantic. New services are coming out, other services are being sunsetted, or people are moving away from them. Paradigms are shifting. That's been really interesting to observe. And we've had to make some, tough calls over the years as to how quickly will we adopt certain new technologies? Will we sunset other things that we've relied on? And so I guess the point I'm making there is really that the fabric that we're building on, the foundations we're building on are ever shifting, and that's been a really interesting ride. I think those have been really interesting challenges. We used to have a really interesting discussion and challenge around homebrew. Actually, we've had some interesting challenges over the years that have come and gone. So we had a really interesting challenge a few years ago around, why should I warehouse my event data? I'm happy with out of the box SaaS tools. Why do I need to build a kind of an archive of my customer behavioral data myself? That was a really interesting debate. I think we won that debate and encouraged a kind of an ecosystem of companies that help you store your event data to places like Redshift. But that was a really interesting debate. We've had another interesting debate at Snowplow over the years, which is around companies thinking of building their own, so kind of homebrew in-house solutions versus Snowplow. Truth be told, those discussions and debates happen less and less often. I think that a couple of things have changed. So I think Snowplow does a lot more than it used to. So, we've had 6 years of building and adding enrichments and adding tracking SDKs, and, just like I mentioned earlier, the tech estate is pretty huge, and I think it's daunting for a lot of data engineering teams that are starting from scratch to think about reproducing a lot of that in-house. I think the other thing that's changed a lot is the data privacy and data protection debate. So where before kind of collecting and warehousing a ton of event data, that was something that could be directed out of a kind of an internal IT team, a data engineering team. Now the sensitivities around that across the whole business. So it's concerning the C-suite, it's bringing in data protection officers, all that kind of stuff. And so having a company out there like us who are thinking about that stuff and thinking about how this stuff should be done properly, and thinking about what's right for data subjects and how do we provide the right tools for data protection officers and stuff like that, I think that's really, really valuable. And that's quite a daunting thing for an internal data engineering to bootstrap.
And what are some of the directions for future improvements or feature additions or business growth that you're focusing on?
So that's a really good question. We're working on quite a few different initiatives at Snowplow, and I think that's kind of inherent in the nature of the platform. It's so kind of broad now that there's a lot of different things that different constituencies are looking for. So one of the most important things we're doing is that expansion to other public clouds. So we're working on GCP at the moment. We're going to work on Azure after GCP, and that's really important because we see a lot of adoption of GCP and Azure. We see customers and users that want to have their pipeline on Azure, not AWS, or they want to have it on GCP instead of Azure, whatever it is. So that's really important. And if we can give Snowplow users that ability to kind of lift and shift their pipeline from one cloud to another, that's really empowering for them. So the public cloud support is really it's really important to us. Auto tracking is really important. So we're really interested in doing more around reducing the integration headache on mobile. So we're doing doing a lot there. And we're really interested in doing more around the data modeling piece. So how do we get more meaningful aggregations, more meaningful bundles of roll-ups and things like that out of the atomic event data? How do we roll the atomic data up into the higher level, more valuable data? So that's another area of focus.
And are there any other areas of discussion that we didn't cover yet that you think we should go into before we start to close out the show?
Maybe just the most interesting uses of the platform. I thought of a few fun ones.
And what are some of the most interesting or unexpected uses of the Snowplow platform or some of its individual components that you have seen?
So there's quite a few. I mean, because Snowplow is really kind of horizontal technology, you can use it to power any kind of event pipeline. Really, we see really diverse use cases, and lots of different industries and different departments inside companies using Snowplow. We have a customer that's building a AAA game and embedding Snowplow in that, and that's really exciting. GitLab, which is an open source competitor to GitHub, they're looking to add Snowplow tracking into the GitLab products. So we're following that with interest. And we also use Snowplow quite a lot internally. So we do quite a lot of dog fooding of Snowplow. So we have various systems that emit streams of Snowplow events, and then we build our own analytics on top of that. So we're using Snowplow for kind of our own operational use cases. So yeah, really diverse set of companies worldwide using Snowplow really in some pretty cool ways.
All right. For anybody who wants to follow the work that you're up to or get in touch, I'll have you add your preferred contact information to the show notes. And as a final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
Oh, that is a really good question. I think as an industry, our kind of comfort levels, our awareness and tooling for working with structured data with schemas, I think that's still really immature, and we'd love to do more on that at Snowplow. I think the pendulum is shifting back towards strong schemas for data and thinking about those schemas up front, but that imposes a lot of burden on various different people in a company. So I think we need to do more. We need to do more around that, around how we communicate, work on, collaborate on schemas together. I think the other side of things, I think the analytics toolkits and this, the interactive studios and stuff. I think that's awesome. I think as data engineers, we probably need more help on the schemaing side of things.
All right. Well, thank you very much for taking the time today to discuss the work you've been up to with Snowplow. It's definitely a very interesting platform and one that I've been considering using for some of my own use cases. So I'm looking forward to digging deeper into that. So thank you for that, and I hope you enjoy the rest of your day.
Fantastic. Thank you so much. Really enjoyed it.